Hello, welcome to Tech Talk with Steve. Years of installation, design, estimation, project management skills in the ICT industry. And that's right out at the end of my cord from my permanent link adapter.
But we did win this great award for Test Pros.
So I've connected my tester here. This is my remote. I've got the plug from the modular plug terminated end of the link. He opened Wilson Technology in 2004. He brings 50 plus years of telecommunications and information technology. Hello, welcome to Tech Talk with Steve, episode 52, DC resistance measurement versus PoE testing. My name is Steve Cowles, your host, product manager with AEM Precision Cable Test. Welcome. Glad you could join us today. So we're going to be talking about a topic that seems to keep coming up, especially with people deploying PoE everywhere. They want to know about resistance. They want to know about testing their PoE. Sometimes you'll hear people refer to a resistance test as a PoE test. We'll talk about that a little bit as well. So I'm going to go ahead and share my screen here, and I'm going to pull up a slide deck here. I promise this won't be death by PowerPoint, but I think it's good to lay a good foundation here so that we can talk about what is PoE testing versus what is resistance measurement. So what's driving this? Internet of Things. It means a lot of different things to different people. The devices we use in our homes and at work, tablets, cell phones, our laptops, those are all IoT devices. Even some of us have cameras that are connected to the internet, refrigerators, things like that. In the business environment, there's other things involved here too. Cameras, access controls, sensors, those type of things, occupancy sensors, lighting controls, all these things are tied in together and part of that IoT. So a long time ago, way back in the day, we had IT and OT, information technology systems and operational technology systems that were traditionally separate. Different types of cabling, different types of technology. They were deployed and managed separately. For the IT stuff, we had category 3 cable. We thought we were hot stuff when we were getting 10 megabits to the desktop back then. Cat 4 kind of came and went, gave us a little more speed, but right on its heels was Cat 5, which took us to 100 megabits to the desktop. And now we're well beyond that. We're talking minimum gigabit speeds to the desktop. If you don't have a gig to your desktop, then you're behind essentially. So now times have changed and these building systems have come together. The OT and the IT are now kind of a blended system in what we call an intelligent building, where your data, your voice, your power management, video surveillance, your environmental, your lighting controls, all these things are tied in over that same network. They're tied in as part of that IoT system, if you will. And we've got power and data running on the same wires, which means that we're going to require more testing. Just certifying that the cable meets Cat 5e or Cat 6 or Cat 6a is no longer sufficient. There's a lot of additional things that we need to be considering after the installation of cabling, or as we'll kind of touch on later, after the cabling's been installed for a while, maybe we're upgrading, we're going to put new applications over the cable, or we just want to make sure that our cable is still in good working order. So we're demanding more from this infrastructure. As we mentioned, LED lighting, phones, client monitors, so your workstation monitors, things like that are being powered over PoE. Displays for conference rooms, large monitors for meeting rooms. You've got things like occupancy sensors that I mentioned earlier, wireless access points, shade controls for your windows can be not only linked via the network, but controlled and powered by PoE. Security cameras and access control. So in this example here, we've got a pretty decent size building, a little over 2,300 square meters with about 750 plus devices and thousands of meters of cable that go into this. So this is why we need to be testing. We've got all these things being deployed. If the cabling isn't going to support not only getting the data to the endpoint, but also making sure that we've got adequate power to that endpoint, then we're going to have issues down the road. So we need to consider what are the additional things that we might need to be testing in addition to certifying the cable based on the standards. What else could be going on? So could noise have an effect on the overall network performance? Is this link going to support multiple link speeds, into the multi-gigabit range? Is the link capable of supporting power, which is the main topic today? We're talking about PoE testing versus resistance. So can it support power on that same pair that's providing the data? So just as the building infrastructure has changed, we need to look at how testing has evolved along with that to accommodate these intelligent building scenarios. So here's a quick snapshot of testing needs. So the first column you see here, your typical certification test where you've got length, delay, loop resistance, insertion loss, return loss, crosstalk, power sum next, ACRF, and PSACRF. So all these things we're used to seeing in a certification test. There are some optional limits as well in here. When we look at the optional parameters for DC resistance, unbalance, both in the pair and between pairs. And then things like TCL and ELTCTL. So TCL and ELTCTL are essentially a test to confirm the noise immunity of your cabling to make sure that you're not getting too much noise ingress. Beyond that, most of your test equipment will have additional parameters, additional functions that we're talking about in the third column here, troubleshooting functions, like a TDR trace for your return loss. So if you have a return loss failure, you can pinpoint where that is along the cable. Crosstalk failure, same thing. It's a TDR trace, shows you how many feet out to that crosstalk problem. Typically, crosstalk is going to be one end or the other, and it'll make it easy to pinpoint where that is. And then shield, which, little teaser here, our next Tech Talk episode, we're going to be talking about that shield integrity test and troubleshooting shield issues. So make sure you tune in on that one as well. And then, other additional parameters that you've got there as well. So the far column here, things that we need to think about for intelligent buildings. Here's where we're getting into beyond the physical cable test. We're talking about a PoE load test that we're going to show you here in a moment, where you actually demand the power from the switch. Checking just to make sure that the switch is present, that you have a power source, those kind of things. Being able to do some basic network troubleshooting to make sure you've got internet connection, those kind of things. Hybrid powered fiber, as well as your network connectivity to make sure that that you can see from one side of the network to the other, discover devices, know what switch port you're connected to, and those kind of things. So let's dive into resistance. So the resistance requirements in order to be compliant for PoE delivery, and this is when we're going to start getting into some of the optional tests. So the first one here, the DC loop resistance, this is required in your Cat 5e, Cat 6, Cat 6a tests as a DC loop resistance. It's 25 ohms. You cannot exceed 25 ohms. So what that means, a loop resistance is both sides of the pair. So 12.5 ohms down one side of the pair, and then coming back another 12.5 ohms there. So that loop, that round trip, cannot exceed 25 ohms. And there's a reason for that. We're going to talk about that. We're going to get into an equation that talks about power drop. That 25 ohms is going to become important. The next one that's not required, but is part of that optional test, is DC resistance unbalance, where we look at the DC resistance, and this one is in pair. We look at the DC resistance measurement of each side of the pair, the tip and the ring of that pair. And we make sure that each of those conductors has a resistance value that's fairly close to the other one. So they need to be less than 200 milliohms difference or less than 3%. Between the two. So there can't be too much of a difference between those two. The next one, again, another one part of the optional, is going to be the DC resistance unbalance between the pairs. So we look at the DC resistance of one pair, and then we compare it to each of the other three pairs in that 4-pair cabling. We do that for every pair. so that you can see that that is also less than 200 milliohms, or in this case, less than 7% of the unbalance between those pair. And again, that's an optional. Now, one note here at the bottom, I touched on this earlier, but a DC resistance unbalance test that we're talking about here is not a PoE test. If somebody's telling you that a DC resistance unbalance test is a PoE test, that's not the case. It is essentially a pre-qualifier to make sure that the cable is ready for PoE and make sure that it's going to be compliant for PoE delivery. And once it's installed and other things happen on the job site, things change, you still may need to do some additional testing to make sure you're getting PoE to the endpoint. We're going to talk about that as well. So why does resistance matter? I squared R power loss. The I squared R is an equation. We'll talk about this a little bit, and I'll try to keep it, at a non-engineering level. In an ideal circuit, you'd have all the power that you connect to that far end at your power source. All of that power would be delivered to that endpoint with no energy wasted or dissipated. So if you had 90 watts of power coming from the switch, you'd get 90 watts of power at the endpoint. But in the real world, that can't happen because there's something called resistance, and resistance will impede the flow of the electrons. Essentially, it's gonna result in a voltage drop over the cable, which when you do your power calculations, your volts times your amps to get your wattage, that's going to be a reduced amount of power, reduced amount of wattage that you're going to get at the endpoint because of that drop. So real circuits have that resistance, and even a small amount of that resistance is going to cause electrical loss. And typically electrical loss is dissipated in heat, which is another reason we want to test the DC resistance and the DC resistance unbalance in cables, because if you've got too much unbalance, you can have issues with that cabling heating up from that heat dissipation, and it's going to cause all kinds of other issues for your PoE and your network. So when we look at this I squared R calculation, we can figure this out pretty easily. So I is your measured current, that's your amps. So in this case, we're using an example, 1.73 amps. We've got a resistance of 6.25 ohms. So that's our loop resistance for this circuit, 6.25 ohms. The I squared, the current squared, 1.73 amps times 1.373 amps gives us 2.99. Now we take our ohms and we multiply it by that, and we get 18.7, and that is going to be watts of power loss. So when we look at a 90 watt PoE link, we've got 71.3 watts delivered. That's 90 watts minus 18.7 gives us our 71.3. So that is how we get to that equation, and this is an ideal link here. So that's where we're getting this 90 watts. This 71.3. So when we look at the allocated power, which is the theoretical number that we can get at the end of that link of a 4-pair cabling, that's where we come up with the 71.3 watts. And again, this 6.25 would be if we had 25 ohms of loop resistance on each of the pairs, and then that boils down to essentially 6.25 ohms. So let's look at another real world example, non-IT related, to talk about resistance and kind of boil it down to why this is a problem, why resistance becomes an issue. So my brother-in-law told me a story. He had a good friend, and her boat wouldn't start. She didn't get the motor to crank. So he went over to try and help her troubleshoot. And so the first thing to look at, now this example shows a meter being connected to the battery, showing the 12.73 volts at the battery. The battery, in theory, you'd think you put the meter on it, the battery looks good. They could measure the same 12.73 volts at the other end of the wire where it was connected to the starter. And it was showing what they assume is good voltage. So the next step is to look at the wiring between that battery and that starter. And without putting a load on the battery, you really can't see that voltage drop. So in this case, when you're measuring it with a multimeter, you don't have a load on there. You're not having the power demanded from that voltage source, that battery. So you don't see that drop. You don't see the drop just measuring it with a meter. And this is the difference when we talk about allocated power that we're going to show you in the PoE diagram here in a moment versus real power. So allocated power is the theoretical maximum that's using that resistance calculation for a good circuit. that we should get 71.3 watts on a good circuit that has cabling in good order, and where we've got 90 watts at the source. So, but without putting a load on, we don't know that we can get that. And allocated power is simply that. It's just the switch reporting what it should be able to give you at the end of that link. So until you put a load on it, you really don't know. So in this case, they basically measure the resistance of the wiring. They disconnected from the battery, measured the resistance of the wiring, discovered that the resistance was really, really high on the wiring going from the battery to the starter motor. And tracing the wire out, they discovered corroded contacts in the wiring. There was a splice somewhere that had gotten corroded. And as soon as you get corrosion, it's going to start increasing your resistance. And that's why resistance is important. So what was happening, there was too much resistance, so we weren't getting enough voltage at that endpoint to turn that starter motor to get the boat motor going. So let's talk a little bit about the optional testing, the regular testing and the optional testing when we're doing that resistance unbalance. So a normal Cat 6A channel test that we see here, this is going to take 6 seconds to run this test, and it gives you all the normal parameters that are required in a Cat 6A channel. And we see here we've got the loop resistance here, and then we also provide in that 6 seconds the unbalanced in pair and the unbalanced pair to pair that we're going to talk a little bit about next. So this is a cable that passed a standard auto test, but then when we change the test limit, and we'll show you how to do that here at the end when we do a demonstration, we change it to the plus parameter, or the plus in this case, where we add the TCL and we add the resistance unbalance. We see now we've got a resistance problem. And if we look at the unbalance in pair, we can see that it is beyond what it's supposed to be here. So we have too much resistance unbalance. So that cable could pass a regular Cat 6A channel test, but not pass the unbalanced test. Now, again, this test is optional. It's not required by the standards, but there are going to be some cases where you may need to do this test. Could be for troubleshooting, could be that your customer wants you to do this, or you just want to do this because you want to make sure your cabling is ready for your power over Ethernet. Another thing to think about when it comes to resistance unbalance, patch cords play a big role in this. I've seen situations where people have replaced patch cords or equipment cords with subpar cords that were really inexpensive, but you get what you pay for. And this can become an even bigger problem on shorter lengths because your patch cord is a bigger percentage of that overall channel. So if you've got a short link, when you combine the patch cords with it, if the link is short, then your patch cords are a bigger part of it, and that resistance unbalance starts to play a bigger role and can cause you some issues with your PoE. So the PoE deployment types. We've got type 1 all the way up through type 4 here, and then the Cisco UPoE. So we'll look at 90 watts as a good example here. So for the 90 watt, the type 4 PoE++, 4 pair, 90 watts. And then here's that number, that 71.3 watts that we talk about. And that's achieved through that I squared R calculation. So that is what you'll see typically if you plug a PoE tester in. It's just checking to make sure PoE is there. In the initial test that we're going to show you here, it will show that number as well. That's the allocated power. It's based on what the PSE is advertising that it can give us. This is what we should get at the end of a good working link, but we don't know what we'll actually get until we put a load on it. So the ability to perform a PoE load test becomes critical in this case because, again, unless we can put a load on it, we don't know how much power we're really going to get to the end. So the DC resistance is important, but this is going to be even more so because once everything's deployed and you've got your power source in place, you can determine, yes, I'm actually getting PoE at the endpoint. This is also a good troubleshooting tool if you need to go in and help a customer who's having issues, whether it's a constant issue or an intermittent issue with a PoE device. Things can happen. A PSE could be misconfigured. Could be over provision. You've got too many devices connected to it that are demanding too much power. I've seen situations where an end customer provided their own PoE switch. They bought a switch online, 12-port 90-watt PoE switch for $100. And any of you out there that have purchased PoE switches or installed PoE switches know for $100, 90 watts, it's not going to be 90 watts on every port. It's an aggregate power. So you get 90 watts for the whole switch. You plug one device in, maybe it works okay. you plug another device or two in, and now all of a sudden you're starting to have problems with your PoE, and you don't get enough power out of that device. And then there's always the blame game. So that's where having a good troubleshooting tool will help. If your certification tester can also do PoE testing and the DC resistance measurements that we need to do, you're ahead of the ball game, especially with that PoE load test. So you've got to have something that you can go in when the phone call comes in and they're saying something's not working, they're pointing at you, blaming your cable. You need to be able to go in and run some tests. So you can exonerate that cabling infrastructure, and then you can end up being the hero and find that problem and help the customer solve their issue. So when we talk about PoE load testing, this initial display here on the left is when we first connect to the PoE. This is a discovery screen, PoE discovery. And some PoE testers, this is all they do. They tell you there's PoE present. They tell you the voltage. They tell you you've got it on all pairs, the PSE type, the power device class, and how many watts. That wattage right there, that's the allocated power. That's 71.3 watts that we talked about a couple of times now. So that is only part of the equation. It's good information to know, especially to know, yes, I have a PSE there, because if it says no and you don't see power, then you've got some additional troubleshooting to do before you can even test that link. You'll be able to select which PoE level you want to test to. And we're going to just leave this at 90 watts. I'm going to show you this here in a moment. We're going to do a test live at the end. So we're going to select 90 watts, but we could do the 30 watt AT or the 15 watt AF or even the 60 watt UPoE. And then we demand a load and we see how much are we getting at that endpoint. And in this case, we're showing we're getting 67.2 watts. So this validates how much power we get at that endpoint. If you're testing this and you see that, yeah, I'm not getting enough power at the endpoint, the next step is to go back to the switch. Let's test into the switch, make sure we're getting enough power from the switch, and then you can start to, by process of elimination, rule out what's causing the problem. Maybe it's that patch cord we talked about. Could be any number of things. So, and beyond this, it's good to be able to run an auto test that will first verify you're getting a good link speed. So, 1 gig, 2.5, 5, 10 gig, make sure you're able to connect. And with an SNR test, you'll determine if you've got too much noise or if your network looks good. If your SNR values look good, that signal to noise ratio, you'll look good. And it'll include that PoE load test with this auto test. You can save this. So now you can provide your customer that extra bit of assurance. So you give them the certification test when all the equipment's deployed. You can do this test on every single link if you wanted and provide this documentation to the customer that, yes, everything looks good. We're getting that multi-gig connection to our access points. We've got PoE at adequate power levels, so all that can be documented. Some other things to think about. So, a lot of times you can use this for troubleshooting, new installations, testing, troubleshooting. Moves, adds, and changes can have an impact on your cable performance over time. So it's good to periodically do some retesting, especially if you start to see a problem creep up here and there. It might be good to do some testing. At the very least, do some spot testing throughout the system. Replacement of patch cords. We talked about this a couple times already. If end users replace a patch cord and they use an inferior user cord or equipment cord of a lower quality or different category, this can cause issues, especially on those short runs where the DC resistance unbalance is a problem in the patch cord and it's on a shorter run. It's going to create a bigger problem for that PoE link. Unplugging and plugging, that mating cycle, when you're unplugging from an outlet, you've got issues potentially with arcing if it's a PoE link that's up and you're disconnecting and reconnecting. It should withstand some of that, but if you're doing a lot of that over time, eventually that arcing can lead to a degradation of the coating, the plating on the contacts in that jack, and start to increase your resistance, and you may have problems. So retesting that cabling over time can help make sure it's still good to provide what you need for your current applications, or especially if you're getting ready to have a future application that you're going to add. We mentioned documentation, so it's going to be really important. You're doing your twisted pair, your fiber tests, your coax tests. You're going to want to have documentation of those. Same thing with the multi-gig testing we mentioned, that includes a PoE load. And if you need to do some network discovery tests to document your switch connections and things like that, all this built into that same certification tester platform is going to be important to have. The documentation is going to provide the end customer proof of quality. It gives the installer protection because you know it was working when you installed it, and it'll support the manufacturer's system warranty. And it will include all the complete test results, the details about the equipment, when it was calibrated, how it was configured. All this information will be in your test reports. So let's go into a demonstration, but I think before we do the demonstration, we've got a couple of polling questions that we'd like to throw out there and get some people to answer before we move into the demo. So the first one, why is the tester showing different resistance measurements on each pair? So you may have caught this when we're looking at the drawing earlier, the screenshot earlier. You'll see that, and you'll see this live in the field when you're running a test with your equipment, whoever's test equipment you're using. You will see, especially the longer the cable is, that there is a difference in the resistance of each pair. So 1 and 2 and 3 and 6 and 5 and 4 and 7 and 8, each of those pairs is going to have a different resistance value. So the question is, why is the tester showing different resistance measurements on each of those pairs? The next question, does the wire gauge make a difference when it comes to PoE? So this one, we haven't talked specifically about wire gauge in this presentation, but the information that we've talked about so far should give you a little bit of a clue. So again, does the wire gauge make a difference when it comes to PoE? So I'm going to go ahead and drop my presentation here, and now we've got wake up my remote unit here. I've got my Test Pro remote right here. I've got a patch cord connected to it, running over to a patch cord here. My Test Pro main is off screen with another patch cord coming in here, and the Test Pro main is being shown right here on my computer. So we're going to go ahead and we're going to run a couple of different tests to talk about resistance. We're going to talk about PoE load. So the first one I'm going to do, I'm going to go ahead and plug in here. And basically I've got a loop cable behind this panel that's connected to these two jacks. You'll notice we got a wire map on our remote. We got a wire map on our main unit, both at the same time. I'll turn that. Hopefully you can get a good view of that screen. So this is what we call live wire map. As soon as I've connected the testers to opposite ends of the link, I get a wire map. So I know if I have a wire map problem, I know that I need to troubleshoot that first. So I'm going to run an auto test. And you can see here my limit is Cat 6A channel. So I'm just running a channel test here. We're doing a Cat 6A channel. And I see I've passed Cat 6A channel. I've got my DC resistance, my wire map. I go into my details. We see network compliance. We know that from the network compliance, we're good up to 10 gig on this. I'm going to go down to DC resistance because we're talking about that. So when we look at DC resistance, the first test here is our loop resistance. I see my loop resistance looks good. It's all within that tolerance level. My unbalance in pair, I see that this is showing an I for informational. So this is a regular test. It's not giving me pass fail, but it is providing the measurement. So in that 6-second test, we're still giving you those DC resistance unbalance. And notice that we see it in each pair, and then we go pair to pair. So every pair is compared to all 3 other pairs. So what I'm going to do now is I'm going to back out of this. I'm not going to worry about saving this test. I'm going to quickly edit my test profile. And I'm going to change this. And instead of doing the regular Cat 6A channel, I'm going to choose this Cat 6A channel plus. And then this is going to give me my DC resistance unbalance weighted with a pass fail. So we'll run that test again. And again, it's still only going to take 6 seconds. We're not adding any time to do this. So 6-second auto test, we've passed. We look at our wire map. We look at our DC resistance. And again, when we look at resistance, we talked about this earlier where resistance could be slightly different on each pair, and you see it is here. And then unbalanced in pair, we see we're well within the specs here. Unbalanced pair to pair, we're within the specs there. So we are good to go. This is past the plus test. And then we can just go ahead and save that test. So we've passed the DC resistance unbalance. We've passed the unbalanced in pair and pair to pair in that plus test. So this cable is good. So the next thing that we might want to do would be a PoE test. So the PoE test, I'm going to keep using my same test pro. I'm not going to need my remote unit. I'm going to pull the remote unit out of the way here because we won't need that for this test. I'm just using my test pro main, and I'm going to keep the same test adapter in here. I'm using my my combination adapter that will do both multi-gig and PoE as well as channel. We've got 2 ports in the adapter. All I'm going to do is switch. I'm going to click on multi-gig to switch my test mode here. I could also just click on PoE if I wanted to do that. It will just activate that port. I'm going to plug into that port now, and what I'm going to do is I'm going to go ahead and connect from my main here, and I'm still going through this same cable. I'm going to pull down the cord that was connected to my remote. I'm going to plug that into a PoE injector that I've got here. So I'm coming from the PoE injector through my panel here and through a loop behind here. And I notice I got a multi-gig connection showing up here. So it automatically detected there's an Ethernet connection. I've connected at 2.5 gig. I can go into, whoops, we don't want to do network test in cloud. That's another function we're not talking about today. I'm going to go to PoE, and we want to look at our PoE and see what we're getting. So our PoE, I'm set for 90 watts, but again, I can choose whichever of these limits I want to use. I'm going to keep it at 90 watts, and here we see that theoretical number, that 71.3 watts. We see we've got all 4 pairs. I'm going to click PoE load test, and I'm going to check this and see if I'm getting PoE at my endpoint at an adequate level. So we're demanding the load from the switch. Essentially, the tester is acting like a PoE device and demanding load. So we're getting 67.79 watts here. I can try to bump that a little to see if maybe I can eke out just a little more, and I can just bump this. It's going to increase it in 10-watt increments. I can get almost 80 watts on this link, so I'm in good shape. I'm fine. There's also an external PoE load test. If I had an external load, we could connect that and monitor PoE over time. But this is more the field test you would use. So the other test that we could run would be that multi-gig test. And I'm going to go into my test limit here and edit this. I'm not going to do any 10 gig. We're just going to do a real quick, we don't want network validation. We want validator. I'm just going to change this, and I'm going to change my limit. I don't want to do 10 gig. I'm just going to do 1 gig and 5 gig. And we're going to go ahead and run our test. And what we're going to do here is, this is the test I was mentioning earlier, where you can do an auto test, save the results showing that you're connecting at these multi-gigabit speeds, as well as measure that power over Ethernet on that link with a PoE load test. And you can save that just like you would a certification test for your end customer. So this does a couple things. It's a good troubleshooting tool, but it's also a value add. So if you're thinking about your customer who wants these certification reports, you can offer this additional service of also, after everything's turned up, running this test to every single link. So we've got a 5 gig, we've got good signal to noise ratio. What we've done here is we put traffic on the line, and we're measuring the strength of the noise in the environment relative to the signal of that traffic that we're putting on the line, and we get that 3.7 dB rating. So anything approaching 0, when you get close to 0, that means your noise is getting close to your signal level, and that's not good. And that's an IEEE limit. You can set that limit to whatever you want. Really, anything over 3, you're going to be fine. We also see we connected fine at 1 gig. We had that checked, and we see our PoE right here. And I'm just going to go ahead and save that. So now I've done both of those tests. So we've shown the DC resistance on balance test. We've shown the multi-gig test with the PoE, and we've shown the PoE troubleshooting test. So now we know that we've got these additional tools, and these are all in the same platform. And what I've showed you today is in our certification test, or the Test Pro, but all these functions are also available, with the exception of certification, are available in the NSA, the Network Service Assistant, and the Physical Cable Test and Network Service Assistant. It's not certification. It's what we call a Cert-A-Lite test. It's qualification plus. So it's using the same required test parameters: crosstalk, return loss, DC loop resistance. All those things are done on the NSA, just like they are on the Test Pro, but they're done from a single-ended perspective into a remote termination device like that. So it wouldn't qualify certification, but it's going to give you most of that same information. So you can use either one, But again, the tester platform is the only certifier on the market that will give you certification plus a PoE test in the same platform, along with the multi-gig test, the network discovery, and all that. So let's take a quick jump over here. I'm going to go back on camera, and we're going to look at some answers to our questions and see what we've got here. So we had some questions from the audience here, and we one thing was somebody wanted to see that adapter we're using. So I'm going to grab that real quick off of my tester. The adapter I'm using is the ADNet cable adapter. So it is a multi-gig and PoE adapter. So the question came in, what is the adapter you're using that you can do a channel certification test and a multi-gig and PoE? And that's our ADNet cable adapter. These are hot swappable. So all your adapters on your Test Pro and your NSA are hot swappable. The ADNet cable adapter is for the Test Pro. The NSA has its own adapter called an AD-NSA channel adapter. It looks almost identical to this, but it's designed to work with the NSA. So what you've got here on top, we've got on this side, we've got a channel test port. Let me pull it up where you can see it. So there's a channel test port right there. And then we go over to this side, and we've got the other RJ45 is our PoE and multi-gig test port. And then you'll see a red and black banana jack on the top of this as well. Those are used for the external load test. When we do an external load test, we're going to run banana cables from this into an external load box, and we monitor it over time. We monitor the signal to noise ratio and the power level, and it stores that in a CSV inside the tester that allows you to do that over time. So that is the adapter that I was using on there. And we got, so the two questions we got, if Jacqueline could pop the first question up again. Why is the tester showing different resistance measurements on each pair? We got a couple answers here, and I see that a couple people have responded with correct answers, worded slightly differently, but they all most people seem to have this one nailed down. So the reason it's showing a different resistance measurement on each pair is that the pair twist on 4-pair cabling is different on each pair, and that's done intentionally to eliminate crosstalk or reduce the crosstalk between the pairs. So if every pair had the same twist rate, then the resistance, they'd be the same length, and they would typically have the same resistance on each pair. But if you did that, then you would increase crosstalk. And crosstalk, if you boil it down, we go old school. Remember the old phone lines when you'd hear somebody else's conversation? Some of you aren't old enough to remember that, but you could hear somebody else's conversation. That's crosstalk. And in the data environment, crosstalk will just kill your data. So they twist them differently so that you can reduce the impacts of crosstalk between those pairs. The next question that we had is, does wire gauge make a difference when it comes to PoE? Most people said yes to this. I think we had a couple no's, but I think most people said yes, it does make a difference. So again, there was a clue here toward the end. We didn't really talk about this, but we were talking about resistance. And if you think about it, a heavier wire gauge, so we compare a 24 gauge Cat6 to a 23 gauge Cat6A. The lower the number, remember, the thicker that conductor is. So a 23 gauge is heavier copper. There's more copper there. Therefore, it means it will have lower resistance, and lower resistance is better. So when you have less resistance, you get more power at the endpoint. So yes, wire gauge makes a difference when it comes to PoE. If I was funding an install for, if it was my money and I'm putting in a new installation, I want to have PoE, I'm going to find what that best cable is, and I wouldn't do anything less than a Cat6A 23 gauge for my my new install for PoE. That would be my recommendation. But money is an issue sometimes, and you only have so much in the budget, and sometimes you can't spend the money for that heavier gauge wire. But seek out cables that will support your power over Ethernet. Cat6A 23 gauge. There's other cables out there that are designed specifically for PoE. There's several manufacturers. So do your research and make sure you use a cable that's going to support that PoE. So I think that puts us, we went a little over today. But I think that's okay. Hopefully everybody got some good information out of this. And as I mentioned earlier, please tune in a couple of weeks for episode 53, where we're going to be talking about that shield integrity test and the importance of shield integrity. So thanks, everybody, and we will see you in a couple of weeks.